is not to scale. This full distance is 46 meters.
Yep.
And then it dropped
1.8 centimeters.
1.8 centimeters. Okay. So, and you're trying to figure out what the flight time was.
Yeah, the bullet's flight time and also the speed as it left the barrel.
Okay. So, when you start out with the picture, and then what do you do to try to get a little bit more information?
Write down gravity.
Yeah, so you've got acceleration, well, you got gravity, but typically what I'll kind of do is like I'll pick the points I'm looking at. So you want to look at this point,
Okay.
and you want to look at this point where it hit.
Alrighty.
And then I'll list a few things at each of those points. Position, velocity, and position, velocity, and time at each of the points. And then the acceleration in between the points.
Okay.
So here you'll have an X initial,
0.
Y initial. You can make it whatever you want. You could make this 0 and that negative 1.8 centimeters. Or just whatever you want to do.
Okay, let's do that. That makes sense to me.
So we'll make that the height of the barrel 0, and then the initial velocity in X, initial velocity in Y. So if it's shot, do you know anything about either of these?
No.
So if you shoot it at like totally horizontally,
Mm-hmm.
what kind of velocity do you have? Sorry, this is velocity initial. Do you have, so if you tried to break it down into components, your X would look like this.
Mm-hmm.
What would your Y look like?
Just dropping the amount of gravity pulled on it? I don't know.
No, the initial velocity, if you shoot it out horizontally, it'll actually won't have any initial Y velocity
Okay.
because it's traveling straight out at that point.
Okay.
So that's one of those things that, so there's a lot of things that you kind of have to pick up yourself. So like these two you picked up yourself, but that horizontal initial velocity, you got to key into that and say, okay, if it's horizontal initial velocity, that means it's just going like this, which means if you try to break it down into X and Y components, it's only going to have an X component, no
Okay.
Y component. So that's going to be 0. And then time here, we'll call it 0. And then our gravity will be negative 9.8.
Yeah, negative 9.8 meters per second squared.
And that's actually our acceleration in which direction?
The X direction, or Y direction, sorry.
Yeah. What's our acceleration in X?
I don't know.
So is there anything that is causing this bullet to slow down in the X direction or speed up in the X direction once it leaves the barrel?
No.
Nope. So this is an object in free fall. As soon as it leaves the barrel, there's no acceleration in X, but there's gravity in the Y.
Okay.
And it's negative.
Okay, I understand.
So then we do the same thing over here. X1, what is it?
46 meters.
Yep. Y1?
Negative 1.8 centimeters.
Or, because everything else is in meters, why don't we change this into negative 0.018 meters?
Okay.
Velocity of X initial, or final, we don't know. Velocity of Y final, still don't know. And then the time is what we're looking for, right?
Right.
Okay. And then do you remember your kinematic equations?
I don't.
Okay.
I I need to memorize those, that's on my to-do list.
That's the first one. And these are simplified. You have to remember that you can use them in X or Y.
Okay.
As long as you only use one or the other. Okay. So we're looking for time. What equation do we want to use?
Let's see, the bottom one?
So this one, does this have time in it?
No, okay, no, I'm sorry, the top one.
Okay, so the top one. So we need a final velocity in X or Y. Do we have either of those? No, so let's go with the middle one.
Okay.
So if you look at it, you have a X final and a Y final, right? So you have zeros. So you have both of those, so that doesn't tell you which one to use yet. Which initial velocity you have?
The Y.
Yeah. So that tells us that we're going to use this equation with Y. And then what acceleration will we use for that now?
Negative 9.8 meters per second squared.
Okay, so we can say Y final is negative 0.018 meters equals Y initial, which is 0, plus what's our initial velocity in Y?
Is it just 0?
Yep. Times t. And then plus 1/2 our acceleration in Y.
Negative 9.8 meters per second squared.
Times t squared.
Okay.
So that's just this equation. We plugged in all our Y values.
And now we rewrite it so that we can solve for t.
Yep. Whoops. 0.018 meters equals, that's all 0. This would be negative 4.9 t squared.
Okay.
Let's divide that over. Those become positive. And you take the square root of it.
Okay. Let's see here. Square root. I got 0.0606.
You got it?
Mm-hmm.
Okay. That's how long it takes. Does that make sense?
Okay, yeah.
Yeah, not even quite a tenth of a second to shoot 46 meters. Okay. So now we have our time, so that's the first answer. How do you find the initial velocity?
Okay. Plug time into. Well, let's see. We need in the middle one again.
Yeah. So our X final is 46. Initial 0. Velocity at X initial is what we're looking for. Times time. 0. Plus 1/2, this is 0, t squared. So 46 equals 0.0606 velocity in X initial.
Okay.
Take this and divide it over to the other side.
Okay. So 46 divided by 0.0606. It's 759.07. That's meters per second.
Meters per second. if you kind of want to check it, I mean, if you know a little bit about like velocity of like firearms and stuff, so you can double this, make it like 1,500. And that's about what this is in miles per hour. So this is about 1,500 miles per hour.
Okay.
And then each mile per hour is about 1.5 feet per second. So that'd be about 2,200 feet per second.
Okay.
Which is, and it's pretty quick, but it's a reasonable velocity for a gun to be shooting like that.
Alright. So, can we go over how you know which equation to use again? I'm a little rusty on that.
Yeah, so basically this is why it's so important to list out this stuff like this. Because these are the options that you have for plugging into your equations, right?
Uh-huh.
So when you look at your equations, instead of having, so imagine we didn't do this yet. When you look at your equations, if you just have this and you know, your picture,
Yeah.
then you're gonna have a hard time deciding which one is gonna work.
Yeah, see, I basically had that in gravity when I started.
Yeah. So what you want to do is just pick the points that you're interested in, usually the beginning and the end, and then sometimes a middle point, maybe 2 middle points if things change.
Okay.
And you list the position and the velocity in x and y, and then time at each point. And then the acceleration acts in between. You do that in x and y.
Okay.
Once you have that, then you take your equations and you look at them, and you say, well, I'm looking for time. So what's an equation that has time in it? You're like, okay, well, these two can rule this one out pretty quick.
Okay.
Then you say, well, what information do I have? This one would be great. I'd love to use this one because it's so simple. Do I have a final velocity? No, I don't. So that rules that one out. Well, let's look and make sure this one will work before we get into it. We have final positions for x and y, and initial positions for x and y, so we could use either one so far. Initial velocity, okay, well, we only have initial velocity for y, but we can still use y. And then acceleration, we say, okay, we've got the acceleration in y.
Okay.
So you just look at what you know, or look at what you're looking for, find an equation that has that. That'll always rule out one of the equations.
I see.
Because, well, actually, unless you're looking for acceleration, because acceleration shows up in all of them. But if you're looking for position, it'll rule out this one. If you're looking for a final velocity, it'll rule out this one. And if you're looking for acceleration. But anyway, you just look at the one that won't work. Oh, if you're looking for time, it rules out this one.
Okay.
So you look at, to make sure that you're using one that will find what you're looking for. And then you take those ones and see how much information you have and which ones you can use. And then as you do it more often, you get pretty good at it.
Okay. Yeah, I really got to get those memorized. Like we get a little note card test, so I've just been writing them down.
Yeah.